This is the take-home practice quiz 4.1 to 4.2 help video. Taking a look here, I'm going to go through these 10 questions. We're going to write using two other notations. So it says 7 to 8. One notation would be using words, 7, taking that word 2 and translating it to a colon, 8, or a fraction, 7 over 8. Both of those is the same ratio as 7 to 8. Says there are 13 books on a shelf. 4 of these books are new. The rest of them are used. What are the ratios of the books? It's really important to just do a quick visual. So there's a shelf, and there are a total of 13 books. And 4 of the books are new. Which implies that 9 of the books are used. Now, once you have a visual, it's super easy to answer these questions. It says, what is the ratio of the used books to the new books? The used books is 9 to the new books is 4. What is the ratio of used books, which is still 9, to all the books on the shelf, which is 13? So, for problem number 2, the best advice is draw a picture of the given scenario. Problem number 3 is solving for proportion. The most important thing to remember is you cannot cross cancel. You must cross multiply. Cross multiply. Once you cross multiply, then you solve. And yes, fractions are totally okay. Keep that in mind and do not assume you're wrong simply because you have a fraction. So I have 12 equals 7u here. And we divide both sides by 7. No, it is not a whole number. Yes, that's totally okay. And Alex is going to want it as a fraction. Number 3. Number 4. A certain drug company is made from only a certain drug. Is made only from 2 ingredients, compound A and compound B. There are 4 millimeters of compound A used for every 7 millimeters of compound B. So keep in mind what you just said, for every, that's a ratio. So compound A, we have 4 milliliters of compound A used for every 7 milliliters of compound B. Now it's asking if the chemist wants to make 759 milliliters of the drug. So that's total of the drug. How many millimeters of compound B are needed? So we're going to treat this ratio as variables. So 4 times a certain amount plus 7 times a certain same amount equals 759 total milliliters. And then you're going to solve for x. This is 11x equals 759. 11, 11. So I'm going to go 759 divided by 11. I know that that goes in there 6 times. 66. That becomes 99. 11 goes into 99 9 times. So our value for a single portion is 69. But we need 7 of that for B, for the B compound. So we're going to times by 7. So the total amount of the B compound is 483 milliliters. Number 5. It says right here that these shapes are similar. The minute you know something is similar means all you have to do is match and mirror. Match the sides up and mirror the direction of the proportion. Match and mirror. So that means this X matches with this corresponding side. Then you find any other matching sides. Doesn't matter which one. Now I'm going to mirror the directions. So I'm going to go left to right. You can go right to left. It doesn't matter. We cross multiply. We come in the margin and do 5 times 7.2. Ends up being 36. And our unknown here is 9. Match and mirror. I'm going to take a picture of this and get extra space here. So problem number 6 says a pole casts a 3.5 tall. A pole that is 3.5 casts a shadow that is 1.77 millimeters long. At the same time, a nearby building casts a shadow that is 48.25 millimeters long. How tall is the building? So what we have here is we have a pole that is 3.5 meters casting a shadow of 1.77 meters. And whenever you cast a shadow, it's always at a right angle to the object. And then we have a building nearby that casts a shadow which is 48.25 meters. The height of the building we don't know. 2 things are going on here that are super important. Anytime you have shadows and objects, we're at a right angle under normal circumstances. Also, because we're dealing with sunshine, the angle up back towards the sun is also the same. So we can deduce that these triangles created are similar by angle similarity. Once we understand that they're similar by angle similarity, then we can make a proportion. Now we go back to match and mirror. Really important since this involves units. We check meters, meters, meters. Everything's in meters. We're already in the same unit. So now I'm going to go match and mirror. Match, mirror the direction, match, and mirror the direction. And you cross multiply. So I have 1.77x equals 3.5 times 48.25. I'm going to divide out the 1.77. So to find the value of x, this is what we're going to do. And yes, with all these decimals, you can use a calculator. So we go 3.5 times 48.25, make sure you hit the equal sign there, divided by 1.77 equal sign. And then it says round your answer to the nearest meter. Because it says nearest meter, that means whole meter. Very important. So we are approximately 95 meters here. Match and mirror, match and mirror. Problem 7 is very similar. Draw a picture, show a diagram. It says in the triangle below that CD and FG are parallel. Once you have parallel lines, you have both similar triangles and proportional segments. EF is 12. CD is 49. FG is 21. Find E to C. Now, it is hard to see this, but if you pull the triangles apart, it becomes quite easy. Let's pull it apart. Right here, the smaller, we have 21 and 12. And then this would be our unknown, our 49. And because of the parallel lines, we know these triangles are similar, which means we can match and mirror. So I'm going to go left to right. 12 over x equals left to right. 21 over 49. Reduce on one side if it's possible. It makes it easier. I know 7 goes in here 3 times. 7 goes in here 7 times. Now we can cross multiply. 3x equals 12 times 7. The key to multiplying is not multiplying. So notice I did not multiply the 7 and the 12. I simply divide out that 3. So x is going to equal 28. Number 9 is a very similar problem. Let's see if we can't see how to work it. So we have F to G is 16. And HE is 15. And FH is 20. And we're looking for GD. Now in this one, instead of looking at similar triangles, instead of pulling the triangles apart and seeing similar triangles, we can visualize this as proportional segments. Remember that optical illusion, the old hag versus the young lady? So in this case, we are proportional going this way. 16 over 20 equals x over 15. Cross multiply. Super important. You do not need to multiply that 16 and 15 out. Let me show you my little trick. The key to multiplying is not multiplying, it's factoring. So we're going to divide out the 20, and then I factor it down. So step 1 is I'm going to factor the 16 and the 20. I know 4 goes into both. 4 goes in there 5 times, 4 goes in there 4 times. Then I'm going to factor the 5 and the 15, and I get 3. So our unknown here is going to equal 4 times 3, which is 12. Now, super easy to check your work. So you simply check the ratio. 4 goes in there 4 times, 4 goes in there 3 times, 5 goes in there 4 times, 5 goes in there 3 times. There's your ratio. We're going to decide whether or not the triangles are similar. If so, state the reason. Let's check. Short. So we have here short is 3, short here is 5. Medium 4, medium 6, long 6, long 9. So we have a 3 to 5 ratio here. We can't reduce that. 4 to 6 reduces 2 to 3. 6 to 9 reduces 2 to 3. However, this is 4 to 5. The ratio is not the same all the way around. Therefore, it is not similar. Let's take a look here. We have a right angle, so we have at least one congruent angle. If this is 55, that forces this angle to be 35. If that's 35, that forces this angle up here to be 55. So these triangles are similar. And that would be JKL. So JKL is going to match with HIG. And the reason is angle-angle similarity. Take a look here. The only thing we have are vertical angles. We have absolutely nothing else to go on, so they are not similar.